entry to the limb was primarily one of just making it livable, the batteries, the power, the glycol loop flowing, etc. At this time, it was obvious that the command module cryogenics were effectively lost because we had done all that we could. We wanted to retain an alignment on board the lunar module because we knew we had to do a maneuver coming up, and because it is difficult to do alignments with the telescope while you're docked to the CSM. In order to do that, we put a battery on the command service module buses in order to supply some more power. We did this when we figured the fuel cell had just about breathed its last oxygen. We put the battery on and we used it for about 20 minutes, perhaps 30 minutes, while we were performing an alignment, which then gave the lunar module a good attitude reference system. The attitude reference system is mandatory to do a proper burn. It's the system that points the vehicle and the engine, and it's the system that then controls the burn. At about 58:40, as I recall, 58 hours and 40 minutes, we turned the command module power down completely and took the battery off the bus. At the very end, prior to putting battery A on the bus, we had used it previously. We charged battery A for a short period of time in the hopes of getting a little more current in. The 3 entry batteries in the command module, of course, will be the batteries they will use for entry. And I should say that they are in fine shape. The command module, which is the portion of the vehicle which will re-enter, is, as near as we can tell, in fine shape. We have electrical power, we have a coolant system, we have a command module RCS system, 2 of them actually, and all the other systems are still in fine shape. We've powered the guidance and navigation system down, of course, but we can power that back up prior to entry. At about this time, then, we had to start configuring the lunar module in a fashion that would allow us to fly. We were looking at the fact that we knew we had to make a maneuver at about 79.5 hours, which at that time was about 19 hours away, and we knew we had to do that on the other side of the moon, so we started to talk about how best to configure the lunar module to get to that point. We did not want to lose the alignment that we had established in the lunar module, and at the other hand, we didn't want to spend too much power because we are fairly limited in the power that we can supply, and the biggest users in the lunar module are the LGC, the computer, and the platform. So we were concerned with that. However, in my mind, we had essentially a safety problem in wanting to retain the platform. We wanted to do as accurate a burn as possible, so that in my mind there was not too much question about turning the platform down as long as we could get enough out of the consumables to safely conduct the burn and use the lunar module as a lifeboat on the way back. Merlin Merritt, who's watching these systems in the lunar module, was very concerned about the status of our consumables at this time, because when we first powered up the lunar module with the coolant system, larger than normal amount of water was being required to cool the vehicle because it had gotten warm, and the initial flow was taking some time to establish an equilibrium, and we at first were looking at fairly high water usage rates. These subsequently slowed down and they continued to get better, and as time went by it became more and more clear that we wanted to leave the computer and the platform up, and that we would have the consumables to do the job all the way home, and I'll talk about those towards the end. At about 60 plus 23, we informed the crew that we wanted to perform a free return maneuver very shortly. Now, the logic behind this was that we had the situation which I've described in the lunar module, and we had about 19 hours to go to the burn to bring us back home. At that time, without any further maneuver, we would not have been returning to the vicinity of the Earth. So we felt it was wise to spend the time and the consumables at that time to do a small burn. It was about 38 or 40 feet a second, which put us essentially on a free return path back to the Earth. This loops around the moon. We're still not sure of exactly what altitude we'll go by the moon. We targeted for about 137, and it'll probably be higher than that, although that's still being tracked. and worked upon, and I'm sure you'll